Hello students, welcome to today's session of chemistry. As you all know, we started studying 7th lesson of your syllabus, that is elements of group 16, 17 and 18. We call them P block elements. In the previous two sessions, we started studying about the compounds of elements of group 16, in which we learn about ozone, which is the compound of oxygen, and we learn about SO2, sulfur dioxide, and sulfuric acid. Those are the compounds of sulfur. So, these are the compounds of group 16 included in your syllabus. Now, we are going to start with group 17, which is halogens. And in this session, we are going to learn about chlorine and compounds of chlorine. So let us start with chlorine. The steps we are going to follow are the same. That means we are going to learn about the methods of preparation, then physical properties, then chemical properties, and lastly uses of chlorine. So let us start with methods of preparation of chlorine. The first method we are going to learn about is oxidation of hydrochloric acid, which gives you chlorine. But for that, we have to use oxidizing agent such as manganese dioxide and potassium permanganate. These oxidizing agents, on treatment with HCl, remove hydrogen from HCl, hence, this is oxidation. So, MnO2 on treatment with HCl gives MnCl2 and chlorine along with water. In the second method, potassium permanganate, which is again oxidizing agent, on reaction with hydrochloric acid, gives you chlorine and the compound form are KCl, MnCl2, H2O and chlorine. So this is again oxidation because hydrogen is removed from HCl. So these two, manganese dioxide and potassium permanganate, are oxidizing agent which bring about oxidation of hydrochloric acid to give you chlorine. This is a laboratory method of preparation of chlorine. Second method of preparation of chlorine is by the action of concentrated sulfuric acid on a mixture of sodium chloride and manganese dioxide. This reaction takes place in two steps. In the first step, sulfuric acid on treatment with common salt, that is NaCl, gives you HCl along with sodium hydrogen sulfate. And this HCl in the next step reacts with MnO2. As you know, we learned this reaction, and this is oxidizing agent that converts HCl into chlorine by removing hydrogen. Hence, in the second step, MnO2 with HCl gives you MnCl2 and chlorine along with water. So together, if we summarize these two steps, the reaction will be like this, because we have taken as an ingredient sodium chloride and manganese dioxide along with H2SO4. So these three react together to give you NaHSO4, MnCl2, Cl2 and H2O. So remember both the reactions, you have to give both the reactions or give this summary of the two reactions. So this is second laboratory method of preparation of chlorine. Now we will see the large scale preparation of chlorine, that is industrial methods of preparation of chlorine. The first process we use for that is a Decans process, in which chlorine is manufactured by oxidation of again HCl by atmospheric oxygen in presence of CuCl2 as a catalyst at the temperature of 723 Kelvin. This is large scale preparation of chlorine, in which HCl directly oxidized by using oxygen in presence of a catalyst CuCl2 and temperature of about 723 Kelvin to give you chlorine and water. Second is electrolytic process. As you know, electrolysis we learn uh, in previous sessions that it has one vessel in which two electrodes, anode and cathode, connected to a battery are placed, and that vessel contains electrolyte. Now, the electrolyte in this process where we are going to prepare chlorine is brine, solution of brine. Brine means concentrated NaCl solution. NaCl in water is called brine. We are going to bring about electrolysis of brine, and where NaCl is used, it gets separated in Na plus and Cl minus when anode and cathode are connected to battery. That gets separated or ionized into two ions. Now, as it is a salt, it gets separated into ions. Now, Na plus, as it is positively charged, it will go to negatively charged cathode. As we have used a solution, Na plus is liberated at cathode in the form of NaOH. Chlorine, as it is negatively charged, will liberate at anode which is positively charged. And the reactions are going on at anode and cathode are like this, where cathode, first we have taken brine solution, so water is there, it gives you OH minus ions along with H plus ions. These OH minus ions will react with Na plus ions at cathode and give you NaOH. While Cl minus ions will be liberated at anode and will get converted into chlorine gas. Thus, by electrolysis of NaCl or solution of brine, we get chlorine. So this is second industrial method of chlorine. So we learn about four methods in which two are laboratory methods and two are large scale or industrial methods. Now we will see the physical properties of chlorine one by one. First, chlorine is greenish yellow colored gas. It has somewhat pungent or suffocating odor. It is poisonous in nature. It can be easily liquefied into greenish yellow colored liquid which has a boiling point about 293 Kelvin. It dissolves easily in water to give chlorine water, and it is 2 to 5 times heavier than air. So these are the physical properties of chlorine. Now let us start with chemical properties of chlorine. Chlorine is a very strong reagent. It is located to the extreme right of the periodic table. Hence, it is strongly non-metallic. It is good oxidizing agent. It is a chlorinating agent. So it has tremendous applications, and it is very reactive reagent. So many reactions of this chlorine are there which are included in your syllabus. We will learn one by one the chemical properties of chlorine. As I told you, it is very reactive. It reacts with metals, non-metals, hydrogen, alkali, everything. So start with reaction of metals. Chlorine reacts with metals to form their chlorides. Like Al on treatment with chlorine will give you AlCl3, sodium will give you sodium chloride, iron will give you iron chloride. So, metals easily react with chlorine to give you chlorides. In the same way, non-metals also react with chlorine to form their chlorides. Non-metal like sulfur will form phosphorus chloride, while sulfur will form S2Cl2. So, non-metals also react with chlorine to give you chlorides. Now, hydrogen. Chlorine has strong affinity for hydrogen. It reacts with hydrogen and compounds containing hydrogen and to give HCl, hydrochloric acid. So hydrogen directly will combine with chlorine to give HCl either, or chlorine reacts with hydrogen containing compound to give HCl. So H2S will also give you HCl along with sulfur. So it has great affinity for hydrogen. Now we will see the reaction of chlorine with ammonia in two different ways. In first way, we are going to react chlorine with excess of ammonia, and in the second way, we are going to react excess chlorine with ammonia. The product every time are different. Now, the first way is chlorine. When treated with excess of ammonia, it gives ammonium chloride and nitrogen. With excess of ammonia, it gives ammonium chloride and nitrogen. But if we use excess of chlorine, then ammonia gives nitrogen trichloride along with HCl. That means excess of chlorine, the product is different, and excess of ammonia, the product is different. You have to remember that. Specific question is asked in exam. What happens when chlorine is treated with excess of ammonia, or a question can be excess of chlorine when treated with ammonia? What are the products? So, nitrogen trichloride is an explosive. With excess of ammonia, it gives ammonium chloride. With excess of chlorine, it gives nitrogen trichloride and explosive. So this is the reaction with ammonia. Now we will see the next reaction with alkali. Again, with alkali, it gives two types of reactions. That means in presence of cold and dilute alkali, it gives another product, and with concentrated alkali, it gives another products. That means with cold and dilute NaOH, chlorine gives sodium chloride and sodium hypochlorite, NaCl and NaOCl along with water. But with hot concentrated alkali, it gives sodium chloride and sodium chlorate, NaClO3 instead of NaOCl. So this is the difference. Now, NaOH on treatment with chlorine, but NaOH taken is hot and concentrated, we get NaCl, sodium chloride, sodium chlorate, and water. So this is the difference when chlorine is treated with cold and dilute alkali and hot and concentrated alkali. You have to remember particular question is asked in exam. What happens when it is treated with, or chlorine is treated with cold and dilute alkali or hot and concentrated alkali. Next is reaction with alkali again, but it is dry slack lime. Dry slack lime, that is calcium hydroxide. With calcium hydroxide, chlorine gives bleaching powder. What is the formula of bleaching powder? It is CaOCl2 along with CaCl2 and water. Dry slag lime, again an alkali, it gives calcium oxychloride, that is bleaching powder. So this is all about a reaction with alkali. Now, next is a reaction with hydrocarbons. Which are hydrocarbons? Do you remember? Those are saturated hydrocarbons and unsaturated hydrocarbons, alkanes and alkenes. So, chlorine reacts with alkanes as well as alkane. As you all know, saturated hydrocarbons are alkanes, and alkanes give only substitution type of reactions. So, with alkane, if chlorine is treated in presence of ultraviolet light or sunlight, hydrogen gets substituted by chlorine, giving methyl chloride and HCl. And when one of the hydrogen is substituted by chlorine, and you get methyl chloride along with HCl. So, with all the alkanes, we get substitution type of reaction. That means hydrogen of saturated hydrocarbon, that is alkane, is replaced by chlorine. Now, with unsaturated hydrocarbon, that is alkanes and alkynes, it gives addition product. Because in alkenes and alkynes, there is double bond present, and across the double bond or triple bond, chlorine can be easily added. So it gives addition type of reactions. Now, chlorine with ethene, when it is treated, this chlorine gets added across double bond, giving 1,2-dichloroethane. So this is all about the reactions with hydrocarbons. Now, next we will see the oxidizing property of chlorine. As I told you, chlorine is located to the extreme right of the periodic table, and it easily works as oxidizing agent, and it brings about oxidations of many compounds. We will see few examples. So, ferrous salts are converted into ferric salts and sulfides to sulfates. It is oxidation. Why it is oxidation? So the oxidation state changes while converting from ferrous sulfate to ferric sulfate. So ferrous sulfate on treatment with sulfuric acid and chlorine gives ferric sulfate along with HCl. This is oxidation. As oxidation state is, or oxidation number, if you calculate, you will see there is increase in the oxidation number, which is one of the criteria of oxidation. Same way, sodium sulfide with chlorine and H2 gives sodium sulfate and HCl. This is again oxidation, which proves oxidizing property of chlorine. Again, sulfur dioxide is oxidized to sulfur trioxide, and iodine can be oxidized to iodate by using chlorine. But in presence of water, the reaction is carried out. Hence, they form, instead of sulfur trioxide, we get sulfuric acid, and instead of iodate, we get iodic acid. The reaction is like this. SO2 with chlorine in presence of water gives sulfuric acid. As SO2 is converted into SO3, hence it is oxidation along with HCl is formed as byproduct. Again, iodine with chlorine in presence of water gives HiO3, that is iodic acid, along with HCl. This is again oxidation. Hence, this is the oxidizing property of chlorine. Now, chlorine can also be used as bleaching reagent. Bleaching, as I have told you in the previous session, that bleaching means decolorization or removal of color. So, chlorine in presence of moisture acts as a bleaching agent. It liberates nascent oxygen from water, which brings about bleaching, which is responsible for oxidizing and bleaching property because chlorine liberates nascent oxygen. Now, chlorine on water gives HCl and HOCl, and this HOCl gives you nascent oxygen, and this nascent oxygen brings about oxidation as well as it can work as a bleaching agent. So, organic matter or vegetable matter which is colored in presence of moisture with chlorine gives a colorless organic matter. So this is a bleaching property of oxygen. In presence of moisture only it works as a bleaching agent. So these are the chemical reactions or chemical properties of chlorine. We learned so many reactions of chlorine describing its chemical reactivity. So try to write down all the reactions again and again to remember those, because particular question on any of the property can be asked. So practice and lot of practice is needed to remember these reactions. Now, after chemical properties, now we are going to learn about the uses of chlorine one by one. First, it is used for purification of drinking water. As you know, in water purification plant, chlorine is used for sterilization, that is to kill the bacteria present in the water. For bleaching, it is used for bleaching of wood pulp. From wood pulp, paper is prepared and a rayon is prepared. So bleaching of cotton, textiles, paper is chlorine is used. So this is second use of chlorine. It is again used for the extraction of metals like gold and platinum. That is, conversion of ore of gold and platinum into metals like gold and platinum. That is called extraction, and that in that process, chlorine is used. It is again used for the manufacture of dyes, that is colors, drugs, that is medicines, and some organic compounds such as CCl4, carbon tetrachloride, CaCl3, DDT, refrigerants, etc. CaCl3 is chloroform. DDT, it is pesticide, and in refrigerants, that is cooling agents it is used. It is also used for the preparation of some poisonous gases, such as phosgene, which is a poisonous gas, tear gas. The formula is CCl3NO2. That is, carbon is connected to chlorine three sides and one side is attached with NO2. This tear gas. Again, mustard gas. Mustard gas, it is used in explosive material, that is mustard gas. So these are the uses of chlorine. So in today's session, we learn about chlorine, its methods of preparation, physical properties, chemical properties, and uses. Now the time for assignment. What will be the assignment for today's session? Because there are so many chemical properties, so some particular questions I'm going to ask about. Firstly, write down the Decon's process for preparation of chlorine. Second, what is the action of chlorine on hot and concentrated alkali as well as cold and dilute alkali? Remember, you have to write in particular both these questions. Write down the uses of chlorine. Chlorine has so many uses. Write down all the uses of chlorine. Explain bleaching property of chlorine. Next question will be, what is the action of chlorine on methane and ethene or ethylene, you can say. So these are the questions for today's session. Thank you.